So we have our lesson all about discriminant. And the purpose of discriminant is to describe the nature of the roots. When we say roots, that means the values of x in a quadratic equation. So it will describe the value of the x without even solving quadratic equation. You can tell whether the value of x is an imaginary or there is one value for x. There are two values of x. So that's the purpose of discriminant. So here we have the formula for discriminant. We have D means discriminant equals B squared minus 4AC. Again, D, which is discriminant, is equal to B squared minus 4AC. So that means, before you can apply the formula for discriminant, you need to get the values of A, B, and C. And in order for you to get the correct values, accurate values of your A, B, and C, you must first transform the equation into standard form. You must always do that one. Again, before applying the formula for discriminant, always transform the equation into standard form. Next is get the values of your A, B, and C, and after that, that's the time you proceed to the formula of the discriminant. Now, how do we describe the nature of roots using this discriminant formula? We have here the table. The table will guide us to our description after we use the formula. So now we have the table, and in the first column you have the value of the discriminant. That means after you apply the formula, you have the value of the discriminant. Then next column, types and number of roots. So this is the description of the roots in your quadratic equation. This is the nature of the roots. So that will be the description. And the third column is all about the graph. But we will not focus on that. We just focus on the first two columns. But to give you an idea how the graph looks like, so that's how it is presented in the third column. So for the first column, if your discriminant is greater than 0, that means all positive numbers greater than 0, but it's a perfect square. So how will you describe the nature of roots? So you have two real rational roots unequal. So that will be the description. What if you have greater than 0, but the number is not a perfect square? So your description will be two real irrational unequal. So you see the difference between the two? Perfect square and not perfect square. In the description for perfect square, it is rational. For the description for a not perfect square is irrational. Now how about if the discriminant is equal to 0? Well, we have only one real root. One real root, rational root. That means the values of x, we have two values but they are of the same number. We call it two values but the same number, we call it double root. Okay, so, and then another is, and the description is equal. So that will be the description of your root if your discriminant is equal to 0. One real root, rational root, or double root, and equal. For the last one is, what if your D is lesser than 0? That means all negative numbers lesser than 0. So the description will be not real and imaginary. So now you're ready to describe the nature of roots, but of course we need to solve first. Apply the formula for discriminant. Here we have now our example. Find the discriminant and determine the nature of the roots. We have example number 1. X squared minus 5x minus 14 is equal to 0. Example number 2. We have 2x squared plus x minus 5 is equal to 0. And we have example number 3. We have x squared minus 10x plus 25 is equal to 0. And we have example number 4. 4x squared minus 9x plus 7 is equal to 0. So let's solve one at a time these examples. Let's have example number 1. So we have the equation. The equation is already transformed into standard form. So we'll get a, b, and c and apply the formula. So the formula is b squared minus 4ac. Then the next one is substitution. So you have discriminant is equal to negative 5 quantity squared minus 4 times 1 times negative 14. Next is to simplify. We have now 25 minus 4 times negative 14. Then simplify again. So you have 25 plus 56. Remember, we are multiplying negative 4 times negative 14. So the answer is 56, and then it becomes plus because of the rule of integer. Negative times negative will be positive or plus. That is why in the middle is plus. So 25 plus 56, final answer, you have 81. And what is 81? 81 is a perfect square. So that means, what will be the description of our root? We have two real rational roots and equal. Okay, that will be the description. Very short and easy. We have now example number 2. So we have 2x squared plus x minus 5 is equal to 0. Again, make sure that the equation is in standard form before you apply the formula. And since the example here is already in standard form, go directly to substitution. So we have 1 squared minus 4 times 2 times negative 5. Simplify, so you have 1 minus 4 times negative 10. So same thing will happen. Simplify, 1 plus 41, and then d is equal to 41. What is 41? Perfect square or not perfect square is very obvious. It's not a perfect square. So we have the description. Two real irrational roots and equal. We have example number 3, x squared minus 10x plus 25. So same thing, apply the discriminant, then substitute. So you have d is equal to negative 10 squared minus 4 times 1 times 25. Next is we have simplify 100 minus 4 times 25. And then simplify again. So you have this d is equal to 100 minus 100. And then what will be the answer? D is equal to 0. Perfect square, but the number is equal to 0. The discriminant is equal to 0. So what will be our description based on the table? So you have two real rational roots equal because it's equal to 0. So we have 4x squared minus 9x plus 7 is equal to 0. Same thing, apply the formula. Then, substitution, you have negative 9 squared minus 4 times 7. Simplify, so you have 81 minus 4 times 28. Simplify again, you have 81 minus 112. And when you subtract, your discriminant is equal to negative 31. And what have you noticed? It's negative 31. So that means discriminant is less than 0. So what will be our description? Not real, imaginary. That will always happen if your discriminant is negative number. Okay. We have here additional problems and I will give you time to solve them on your own. So for number 1, same thing what we did in the previous examples. In this case, you will also do the same but with a different problem. Let's see if you understand how to get the discriminant and describe the nature of the roots. So for number 1, we have x squared plus 14x plus 49 is equal to 0. Number 2, we have x squared plus 5x minus 2 is equal to 0. Number 3, we have 3x squared plus 8x plus 11 is equal to 0. And lastly, we have x squared plus 5x minus 24 plus minus 24 equals 0. I will give you few seconds to solve, and this will be the answer. So now, are you done solving? This is the answer for number 1. Your D is equal to 0. So the description is real, root, rational, equal. For number 2, your D is 33. And the description is two real root, irrational, unequal, because your D is not a perfect square. For number 3, your D is negative 68. So what will be the description? It's negative, so not real root, imaginary. And then for number 4, D is equal to 1 to 1. So that means 1 to 1 is a perfect square, so we have two real root, rational, and equal. So, do you get all numbers correct? Well, a round of applause if you get it all correct. But for those who are not, just try. Remember, try and try until you succeed. Okay, let's proceed to another problem. So we have here example number 1, wherein we can apply discriminant to solve this kind of problem. Find the value of k in x squared plus kx is equal to 18 if the equation has real, rational, and equal roots. So in here, we do not know the discriminant, but we are given the equation that it must be that our discriminant should fall into the category of real, rational, and equal roots. Okay, so how to do that? Later you will see. Number 2, find the value of p in x squared plus 10x plus p is equal to 0 if the equation has real, irrational, and unequal. So number 2 is similar problem with number 1. The only difference is the condition. The condition says real, irrational, and unequal roots. So we need to satisfy that condition. And lastly, we have find the value of m in mx squared plus 4x is equal to 12 if the equation has no real root and imaginary. So again, number 3 is same with the problem 1 and 2, but the only difference is the condition. So now, how will we use the discriminant in satisfying the condition? So let's have example number 1. So for example number 1, we have the equation x squared plus kx minus 18 is equal to 0. That means, in the given problem, the equation is not in standard form. So in this solution now, we change the given equation into standard form. That is why this will be our standard form of the quadratic equation. X squared plus kx minus 18 is equal to 0. So now, let's apply the discriminant. So substitute. So you have now k squared minus 4 times 1 times negative 18. Then simplify. Simplify. So you have k squared plus 72. Multiply. And then, after this equation we will use later. We can say that this is your new equation of the discriminant because we have a variable k. We need to find the value of k so that we can solve for that discriminant. We cannot proceed because there is no value for k. So how to find the value of k so that we can proceed? So what will you do is equate it to 0. Your d will become 0. So what will happen is you have an equation k squared plus 72 equals 0. Remember, You cannot solve an equation if there are two variables unknown. It's difficult. So in order for us to solve, we need to equate one variable into 0, and that will be variable d. Now, transpose. So we have square root of negative 72. That will be the value of your k. Substitute the value of k will be d is equal to k squared plus 72. So we have to substitute. So we have here now d is equal to k squared plus 72. Substitute. So we have to cancel the exponent, cancel the square root. So what will remain is negative 72 plus 72. What will be the answer if you have negative 72 plus 72? The answer is 0. Now, your discriminant is 0. What is the description? If your d is 0, you have real, rational, equal. Now, okay, equal. And that is the condition of number 1. So that means the value of k, so that we can get a real, rational, equal description of a root, must be square root of negative 72. Okay, there is no other value of k so that we can achieve or we can satisfy the given condition in number 1. Okay, so now let's proceed to example number 2. In example number 2, we have x squared plus 10x plus p is equal to 0. Again, we need to change always the given equation into standard form. If the given is already standard, then no need to change it. Just continue applying the discriminant. So we have the substitution. We have 10 squared minus 4 times 1 times p. So simplify. So you have the new equation, 100 minus 4p. So this is hanging again because of our p. We need to find the value of p first before we can continue solving the discriminant. So again, equate it to 0. That will be negative 4p plus 100 is equal to 0. Okay. So remember, we rearrange the terms. So instead of 100 minus 4p, it becomes now negative 4p plus 100 is equal to 0, so that we can solve easily. We rearrange. Next is transpose 100. So negative 4p is equal to negative 100. And then, remember, there is a number beside variable p, so we need to eliminate. Divide it by 4. Negative 4. So negative 4 divided by negative 4 will be, the remaining will be p. And negative 100 divided by negative 4 will be 25. So that's why there the answer p is equal to 25. Then now, since we have the value of p, we can continue solving for the discriminant. So we have 100 minus 4 times p. Substitute the value of p, which is 25. So you have 100 minus 4 times 25. So 4 times 25 is 100, and then 100 minus 100 is equal to 0. So if it is 0, our discriminant is 0, what will be the description? Well, of course, it is the same in example number 1. But now, that is not our goal, because our goal to satisfy should be real irrational. So, again, the value of p is 25, but when we substitute it to find the discriminant, it will not satisfy our given condition. So, how will we do it? Well, your basis is the value of p, which is 25. You have only two options. You either go up to 25 or you will go down from 25. So that means any number. So we have here the value of p is 25. But since the value of p does not satisfy the given condition, when we substitute it to the formula of discriminant, the answer will not satisfy to the given condition. Then, if this is the case, you have two options. The first option is you either go up from 25, and the second option is you go down from 25. That means, if you go up, you have 26 and above. If you go down, you have 24 and below. So, what will you do is use the value first. Try higher than 25. 26, ano ba? So it's trial and error now. So you will try, let's say 26. Substitute 26 to 4p. Instead of 25, 4 times 25, that will become 4 times 26. The answer will be, what will be the answer? It's negative. So your discriminant is negative, right? Because 26 times 4 is 104. So 100 minus 104 is negative 4. So your discriminant is negative 4. So that means it will not satisfy the condition. So what if we will try lower than 25? Well, let's say 24. Yes. If you will use 24, substitute it. So that will be 4 times 24 will be 96. 100 minus 96 is 4. Okay. So we can have lesser than 25. Okay, so real, irrational, and equal. So you can have the values of lesser than 25. So the answer, what will be the value of P? P must be lesser than 25 so that you can achieve or satisfy the condition given in number 2. That's why the answer there, P is lesser than 25 to achieve real, irrational, and equal. Okay, so next. So we have now example number 3. Mx squared plus 4x minus 12 is equal to 0. Again, always transform your equation into standard form. And since number 3 is not in standard form, you need to transform it. Then apply the discriminant. Substitute. You have 4 squared minus 4 times m times negative 12. Simplify. You have 16 plus 48m. So again, we cannot solve your discriminant because there's letter m. We need to find m first, so equate it to 0. Rearrange. 48m plus 16 is equal to 0. Then substitute. Then transform. So you have 48m is equal to negative 16. And then divide it by 48. So you have negative 16 over 48. Then reduce. So you have m is equal to negative 1/3. Substitute 1/3 to the discriminant equation. So you have 16 minus 48m. Substitute 16 minus 48 times negative 1/3. And then you have 16 plus 16 is equal to 32. So what is 32? If your discriminant is 32, what should be the description? It should be 2 real, irrational, unequal. But the condition is asking for not real and imaginary. So what will be the value of our m? So you have again 2 options. It's either you go up or you go down. So when we say you go up, that means since the given of m here when we solve is negative, that means when we go up, positive numbers. If we go down, another negative number because it starts with negative, so another negative number when we go down. Let's say negative 1 because this number, negative 1/3, is a decimal number. It's less than 1. So let's say, let's start with negative 1. And then, if we go up, let's say we'll start with positive 1. So, what will be the value of m? So you have 2 possibilities. Let's try first higher than negative 1/3, which is positive 1. So 48 times positive 1. So replace the negative 1/3 there. 48 times negative 1/3, that will become 1. What if your m is 1? So that will be negative 48. Same. So 16 minus 48 is equal to negative 32. So the answer is negative 32. So now, since you get already the answer, if it is negative, diba? The description is not real and imaginary. So the value of our m must be greater than negative 1/3. So that we can achieve the given description or given condition. So that's it. Do not anymore try lower because you have the answer already. Among the three options, equal, lesser than, and greater than, you have only one answer. It's either equal, or it could be lesser than, or it could be greater than. So in this case, equal is not available, lesser than is not available, so the answer will be greater than. So M is greater than negative 1/3 so that we can achieve or satisfy the condition not real and imaginary. And that's all for our discriminant lesson.